Hello everyone, welcome to this session. This is our first class and we are having it online because of the current situation in our country. My name is ch1 and I'll be taking this course Advanced Operating System on behalf of Dr. Lienou Jean-Pierre. Today we are going to treat the first 6 chapters, and these are the Introduction to Operating Systems, Design Principles and Concept, the OS Machine Interface, Operating System History and Evolution, Processes, Process Scheduling. Without much ado, let us start with Introduction to Operating System. What is an operating system? Before getting to the definition of an operating system, it is important for you to note that the system of a computer is organized in form of layers, where the very first or underlying layer is the hardware. Then we have system software, application software, and users. You should understand that each of these layers provide an abstraction for the layer that is just beneath it. For example, system software. System software are a series of softwares that handle specific functions on aspects of the hardware. We could have examples of system software like device drivers, operating systems, utility programs. Now let's take an example of device drivers. An example of a device driver could be the sound driver. The sound driver will handle the sound component of the computer hardware. Since we are dealing with the operating system, it falls in this section, system software. Application programs, on the other hand, are written programs that are installed into the operating system that serve or give user specific functions. Now, a simple way to define our operating system could be that we could say it is a foundation software of a machine that which schedules tasks, allocates storage, and presents a default user interface between applications. Or better still, we could say an operating system is a system software. Say rather than using foundation software, we could say it is a system software. A system software of a machine that which schedules tasks, allocates storage, and presents a default interface to the user between applications. Now, what do you observe? You observe that the operating system is defined using its 3 main functions, which is what? Task scheduling, storage allocation, and provision of an abstraction to the user. When you give a user interface, it's like you're providing an abstraction to the user. So basically, an operating system is a system software that provides an abstraction to the user of the computer hardware. What is the meaning of abstraction? Abstraction means that you are hiding the complicated component or the very hard component from the user. The user does not get to see the complicated part of the computer. The hardware. Imagine you're a novice and you're just given a computer hardware that you should use. You see that is going to be very complicated. But with an operating system, you could actually install application programs like Microsoft Word, or maybe other application software, maybe a PDF reader. PDF reader could be a Foxit reader, and other application software. Microsoft Word will help you to do word processing, and Foxit reader might help you to read PDF documents. So that we can say that is how we define an operating system. Next, kernel mode and user mode. Kernel mode and user mode. Now, the operating system is divided, the computer system in general is divided into two kinds of mode. We have the kernel mode and the user mode. This division is important because it helps to limit the access to hardware resources. Now, the operating system itself, or system software, run generally in the kernel mode, while application softwares run in the user mode. Now, the reason for this is because we have to protect the hardware resources, and the best way to protect that is using the instructions already predefined in the operating system. If the hardware resources are not protected from user applications, the user applications are going to have direct access to the hardware resources, which could be dangerous because they could request and overuse some resources. That is why it is important that to get access to hardware resources, application programs which run in the user mode have to pass through the operating system, which runs in the kernel mode. Kernel mode simply means that they are a privileged mode or an administrative mode, while the user mode simply means that it is the non-privileged mode. Okay. Now, so basically that's what it means between the two. Yeah. (1.3) Other system software. Now, we just spoke about the kernel mode and the user mode. Now, let us now look at what actually is contained between those two modes. We recently said in the user mode it contains mostly application programs. Now, take a look at this section. You notice that in the user mode we have the users and the application software. There are several forms of application software. We have system program, application program, and user program, which contain library routines. These library routines are important libraries which provide sub-functions to each of these user programs. Now, in the kernel mode we have the system calls. The kernel mode starts with the system calls. The system call provides an interface through which application programs could get access to resources in the operating system. Let us take an example. If an application program wishes to use a hardware resource like the processor, it makes a request, passes it through the system call. The system call puts the request in the operating system. The operating system then allocates the resource which it is requesting to the application program. That is the flow. Now, there are several forms of we could have application programs like Mozilla Firefox, Netscape, Microsoft Word, as we earlier said, but Excel. All of these programs are purchased apart from the operating system, and they function just in making the operating system more useful to the user. The operating system, on the other hand, performs functions like copy, delete, making new directories, and things like that. So now let us move on to the next, which is types of operating systems. Types of operating system. There are several types of operating system. We shall look at a very few according to their categories. First, a simple monitor. This type of operating system provides very few services to the user and leaves much control of the hardware to the user's own programs. A good example of such an operating system could be Microsoft DOS. Next, we have the batch system. The batch system takes user jobs, segregate them into batches with a similar requirement, and then each of these batches is given to the computer to run. When these jobs with similar requirements are batched together and given to the computer to run, it streamlines their processing and increases the processing speed. User interaction in this kind of system is lacking because the batches are entered into the computer, then they are processed and the output comes out at a later time. A good example of such a system could be the IBM's VM, the IBM's virtual machine. Again, we have an embedded system. This type of operating system are built into the computer, and they have little or no there is little or no user interaction between the system. Meaning, we just have a hardware with operating system inside the hardware and just performing function. A good example of such a system could be we have Palm Pilot or electronic diaries. So most of these systems are the kind of system that are built into cars, microwave ovens. Yeah. Again, we have the real-time system. The real-time system responds to input within certain time constraints. These time constraints or this input are usually defined by external sensors and not by the human. Thus, there is very little human interaction because the sensors provide the input into the operating system and the operating system acts upon the input received from the sensors. Most real-time operating systems are equally embedded systems. A good example of such a system could be the ch1 operating system. Finally, we have multi-programming system. This kind of operating system appear to run multiple programs at the same time. It equally permits user interaction and allows user response time to be quite efficient with the computer utilization. Multi-programming systems are usually more general purpose and are the best type of operating system for users. That is for people who want to interact with the operating system. Examples of such operating system will have Unix and Microsoft Windows. Now we shall move on to chapter 2, design principles and concepts. Before we go ahead, if you have any questions, you could write it out in the WhatsApp chat, or you put it down as comments below the YouTube chat, and I'm going to respond to you as soon as possible. Design principles and concepts. Here we are looking at the look and feel of the operating system from 2 points of view: from the user point of view and from the programmer's point of view. From the user point of view, we are seeing how application program works, and from the programmer point of view, we are looking at how we use system resources. You see, there are several system resources that are being provided by each operating system, but there are some common resources that that all operating system provide. Now let us look at some of these resources. Let us start with the process. Before we look at what the process is, it's important that we distinguish between process and a program. Now a process between a process and program. A program is a collection of computer instruction with some data that resides on the storage medium waiting to be called into action. On the other hand, a process is a program during execution. A program during execution. That means that the instructions are loaded into the computer's memory, and then it is continuously taking input from the data which is residing on the computer storage, manipulating that input and producing its output. So that is different between a program and a process. To be more specific, we could say that a process is an environment that provides that is an environment for the program to run in it, right? The process is an environment for the program to run in it. This environment protects that program against other processes and also provides the running of the program with access to system resources. These system resources are done through system calls to the operating system. The next resource we are going to look at is the memory. When here we are talking particularly the RAM, random access memory. It is a temporal storage, also called the it's also called the main memory. Also called the main memory. The main memory is a temporal storage medium in the computer that stores the data and instructions of a program during execution. What do I mean? Now, when we say it is a temporal storage, it means that once there is no power, its content is lost. It is volatile, right? Let's say we're working on we're executing a program, and then light goes off. What it's stored is going to be lost because it is volatile. Okay, now currently there are several processes which are involved in a computer. We have there are several processes. Nowadays the main memory comes in larger capacities. At first it was just a few megabytes, but today we have them in thousands of megabytes. That is, we are talking of millions of 8-bit storage areas which are reserved just to store programs during execution. Such memory contents are usually protected, and they are well addressed. That is, we can read and write to each of these memory locations which have an integer address. When we talk of an integer address, we are referring to maybe a box with a certain number in it, like 1. Okay, that could be one memory address, and another memory address could come just by the side of it, you know. Actually, you know, it's like a story building with several rooms in it, and then each having an integer address like that too. So that is how the memory storage is arranged. Again, now these memory storage are usually allocated by the operating system to each process. Not all. So it is the operating system will decide what quantity of the memory to allocate to a running process, as well as a process could request for more memory during its execution, and it will equally relinquish that memory when it no longer needs that memory. So that is it about memory. We shall move on to the next system resource, which is Files. Files. Files are storage for programs, source code, and data and documents. They can be accessed by processes, but they do not appear in the process directory, or they do not disappear when the process dies, or when the machine is turned off. Does this make files persistent? It means that files are permanent storage, are permanent. Now, operating system provide several mechanisms to manipulate files, such as we could open the file, we could create a new file, we could read and we could write in a file. All these are operations which the operating system provide. Again, as part of the job of providing extraction, that is hiding the hardware from the user, the operating system has the ability to provide abstract services to application software. These kind of abstract services include helping the application software to organize files on the various sectors on the hard disk drive. Again, the files are differentiated from their structure, because we have files that could be very large, we have files that could be very small, and we have different types of file. So the best way to differentiate these files is by differentiating from the structure. Let's take an example. A Word file will have the extension .docx. A Word file will have the extension .doc. A text file will have the extension .txt. An image will have the extension .png, or .jpeg. I believe that's it. Yeah. So these are different types of files, and the great thing about it is that the operating system allows to have permissions, meaning that you could decide if you want your file to be read only, or it should be read and write, or all that depends on you. Now, in order to better organize these files, the concept of directories have been introduced. Now, a directory is what we locally call a folder. Now, a directory has the ability to group several files together in one directory. So this helps the better organization of files logically for the user. Windows. Nearly all operating systems provide some form of graphical user interface for the user, although most of such operating systems equally come with a command line interface. Now, in operating system, so this graphical user interface permit the easy usage of the computer by providing an abstract concept of what we generally know as a window. A window is a frame, some sort of a rectangular drawing area on the keyboard, which contains information about maybe a particular application software, and the window also comes with icons which permit the window to be destroyed, resized, or hidden. When we talk of destroy, we mean that you close the window. The operating system equally maps the logical window to the physical display area of the computer, which is provided by the computer graphic card and the computer graphic or video card and the computer monitor. Now you're going to map the size of the window to that, so that the user can be able to perceive fully the information which is being displayed in the window. This is and then the operating system equally permits the user, or it equally directs the input. That is, for example, if we have a keyboard and mouse connected, the operating system will be able to permit the mouse to perform actions like switch between windows. That we see that it is changing the input focus. Operating system services. See, from the programmer's point of view, an operating system is defined mainly by an application programming by the application program interface that it provides, and to a lesser extent the library routines that are available. Now, it follows that different operating system products may provide exactly the same application programming interface, and it appears that the operating system will run similar programs. An obvious example of such operating system is the Unix. You see, Unix is not a single operating system, but it is a collection of operating systems that they share a common application program interface. Now, let us call application interface application program interface API for short. Now, it's that these APIs, the API for Unix have been standardized to provide several sub-distributions like POSIX, Solaris, HP UX, Score Unix, Digital Unix, System V or System 5, Linux, Minix, FreeBSD are examples of Unix operating system. Now, what this means is that if you run one program on a Unix platform and you recompile that and the program is recompiled, it will run on a Unix system. Now, it is going to run on any of the Unix system as long as the system calls for both systems are the same. For both systems are the same. Now, another group of operating systems which share a common API are the Windows system. We have Windows 7, Windows 8, Windows 10. But if we write one program, that program will be able to run on the 3 different versions. Why? That is because though they are structurally different, that is the look and feel is different, but the application program interface is the same for the 3 operating systems. That is why you can write one program and it works for each of the versions of the operating system. Unix and laboratory work. Well, during this course, we are going to work using the Linux, one of the Unix distribution, which is a Linux operating system. It is not actually specific, but we want to just demonstrate to you the features of an operating system. So that is what we are going to do practically. Now, structure of an operating system. The operating system structure is completely dependent on the designers, and it's usually hidden from the user. So the user usually have little no idea about the operating system because the application program interface provides a certain look and feel for the user. Now, there are two main structures of operating system. So there are two main designs of operating system. We have the monolithic model and the client server model. Let us start with the monolithic model. In the monolithic model, the operating system is written as a collection of routine. Each of these routine can call any of the other routines when needed. At build time, each routine is compiled and then they are all linked together to form a single program. We call this program the operating system kernel. Now, when the operating system is started, the kernel is loaded into the computer's memory and it runs in the kernel mode, or what we call the privilege mode, most of the versions of Unix, we could have Linux, monolithic Linux, yeah, like Linux, they use the monolithic design model. During our practicals, we are going to, see actually how that design looks like. But monolithic model suffers from the fact that every part of the operating system can seal the other part. This makes it easy for a bug to be planted, and if a bug is actually planted, it's going to destroy data that another routine might be using, and recompilation of the entire kernel, it's a slow process and it's kind of painful too. To reduce this shortcoming, designers have decided to place an overriding structure on the operating system design, which hides several subroutines. So only the routines which need the other routines will obtain visibility of such routines. Now, because Unix is monolithic, nothing stops one section from the operating system from calling another function from calling another using function call. Now let us take a brief look at the structure of the internal design structure of a monolithic system. Now generally this is how a Linux operating system looks like. Yeah, it's divided into two main modes: the user mode and the kernel mode. Okay, the user mode and the kernel mode. Let me just differentiate. We have what? User mode, and also have the kernel mode. Now in the user mode, our interest is not in this section. Our interest is not in this section where we have the user mode, but we place our interest rather in the second section of the kernel. Here we have the system call interface links the several functions which the kernel offers to the user interface. Now we will have what? Memory management, process management, file management, the terminal management, network management, and also the kernel libraries. You have to note that the libraries the libraries in the kernel is quite different from the libraries in the user interface. That's because when programs are running in kernel mode, they do not request anything from the user interface. If they require a particular function, the kernel library is going to provide a function. An example of such a function could be the print k function. The print k function, which simply displays what is being stored in which is like it's a print function. It displays what you want it to display, but this time around it's been provided by the kernel libraries. So that is the structure of a Unix kernel. Any distribution of Unix will have it. Next, we shall talk about the client-server model. Client-server is an alternative design method for operating system, and it tries to minimize the chance for bugs to appear in one part of the operating system. Now, in this model, what actually happens is that the operating system services run in a privilege mode, and the processes that runs in this privilege mode are called servers. They are quite different from the local processes, because the local processes run in the client side. What happens is that if a client needs a service, is going to send a request in the form of a message to the server. The server is going to perform the action on behalf of the client and then send a reply, as you can see on this diagram, where we have different client processes or they run in user mode. When they need a service, they send a message to the kernel. The kernel to the they send a request as a message to the kernel. The kernel then performs the action. In the kernel, we have servers there. They perform the action and then send a reply. An example of such a system is a Windows NT system. Now, this diagram indicates the Windows NT system where we have several applications. We have the logon process. The logon process will send a message in the form of will send a request in the form of a message to the security subsystem, which is also a server, and then it is going to be processed, and then the request will be sent back to the logon process for it to continue.